Welcome to this online session, and today we are going to see the interesting topic called force and pressure. So what is force? So if an object is at rest position, if we give any external force to move that object, that is called force. Now the pressure is nothing but the force per unit area is the pressure. Today we are going to see some interesting topics based on the force and pressure with good examples. Now let us go into the presentation. So what is force? So as I have told you, force is a push or pull which changes or tends to change the state of rest or of uniform motion and even the direction of the motion or the shape and the size of the body. Now a force is a vector quantity with the magnitude and the direction. So the SI unit of the force is Newton. We can represent it as in the letter capital N. Now what are the effect of force? So force can change the state of rest or of a motion of an object. Likewise, it can change the size of the object, the shape of the object, the speed of the object, even the direction of the motion of an object. Now we are going to see how the force can change the direction of the motion of an object. So you can clearly observe it from the image. A force can make a stationary body to move, like when you kick a stationary football, it moves. So you can see the players are kicking out the football. Therefore, there is a change in the motion, that is direction of the motion in an object. Likewise, another one, a force can stop a moving body. So here in a cricket, a fielder catches a moving cricket ball to stop its motion. So we can change the direction as well as we can stop the moving object. So here the force can change the shape and size of an object. So when an inflated balloon is pressed between the two hands, we can keep the balloon in between our hands, and when we press it over, its shape and size will change. Likewise, when a ball of a wheat flour is pressed, when we pressed, its shape will change. In fact, it can be given any shape. So when your mother making chapati or puri, she will make the wheat flour, no? That time you can experience how the force we are giving, how the shape of the flour is changing, you can experience it. Likewise, the another one, the shape of a toothpaste. When you buy the new toothpaste, how the shape will be? It will be a normal one. But by using every day, the shape of the toothpaste tube will be changing by giving the pressure. So these are the best examples that force can change the shape and size of the object. Now we are going to see what are balanced force. So if a number of forces acting on an object does not produce any change in its state of rest or of uniform motion or the direction of the motion, and then it is called the balanced force. That will not produce any changes. So when minimum two forces are equal magnitude but acting in opposite directions on an object simultaneously, then the object is continue in its state of rest, or if it is moving, it will continue to move in a uniform motion in a straight line. Such forces will act on the object known as balanced forces. So there are two examples here given. So the game tug of war. Have you heard the game tug of war? You people will play, no? In sports day and all, kairi little. So two parties will be there. Both the team will give their external force, that is the maximum force on their directions. So this was the best example of a balanced force. If both the teams gives the equal force, there won't be any changes in the which side. There will be no changes in any of the side. Likewise, holding a briefcase with a hand. So it will, we are holding it in the middle. So it is balanced force. Likewise, we are going to see what is unbalanced force. So if a number of forces acting on an object will produce a change in its state of rest or of uniform motion or even in the direction of the motion, then they are called as unbalanced force. So here also there are two examples. A stone is dropped from a top of a tower to down. So it is unbalanced force, that's why it collapsed the thing in the ground. Likewise, when we drag a box, so here in the image you can see a boy is drag a box to the floor. So in force there are two classes, that is contact force and another one is non-contact force. So first we will see contact force. So contact force is a force that is applied by the objects in contact with each other. So for example, they have given muscular force, mechanical force, frictional force, likewise tension force. So let us see one by one. The force extracted by the muscles is called the muscular force. Here the force extracted by the machine is called the mechanical force. Likewise, the resistance into the motion experienced when two surfaces in contact move with respect to each other is called friction. Likewise, tension is the force extracted by the string or ropes or fibers and cables when they are pulled. So these are the best examples of the contact forces. Now in non-contact force, a non-contact force is a force which acts on the object without coming physically in contact with. That's why it is called as non-contact force. For example, gravitational force. If a fall of apple from the tree to the ground means, it is a best example because there is no contact between the fruit and the ground, but it is happening due to the gravitational force. Likewise, electrostatic force and magnetic force. So force with which objects pull each other is called gravitational force. And electrostatic force is nothing but the force between electric charges. And the magnetic force is nothing but force extracted by the magnets on each other and on metals like iron and nickel. It is the magnetic force. So here comes the pressure. Pressure is defined as the force per unit area. So the SI unit of the pressure is Pascal, that is represented as PA, and which is Newton per square meter. So the formula for the pressure is equal to force by area, that is P is equal to F by A. So let us see some practical applications of pressure. The nails and pins have pointed ends. So you will notice you have noticed that the pins and the nails, so that will have a pointed pin because it has a small area. So the force on the head of a pin or a nail will exert considerable pressure to drive it into a surface easily. So we can give only a small amount of pressure, then the nail will get into the surface. Likewise, a camel can walk easily on the sandy surface than a man in spite of the fact that the camel is much heavier than a man. It is due to the camel will have a small area path. That's why even the camel can run in the sandy surfaces. But our human being, we will have a feet of a man will yield a large pressure. Therefore, our leg will go into the sand and it will very difficult to walk on the sand. But the camel can even run on the sand. Here comes a sharp needle pierces the skin easily but not the blunt needle. So why it is? The area under the pointed end of the sharp needle is very small as compared to the blunt needle. So the pressure extracted by the sharp needle is much more than the pressure extracted by the blunt needle. Here comes the another practical application, that is it is very painful to hold a heavy bag having a strap made of a strong and thin strip. So that you can clearly observe it from the image. So when a large pressure is extracted by the strap on our fingers or shoulders, and this is due to the large pressure, the strap tends to cut the skin and hence pain is caused. So these are the practical applications. Thank you.